back, folks, to another video by VU3 Golf Whiskey Number Radio on how to make a end-fed antenna, end-fed half-wave antenna. In one of my previous series, I have demonstrated how to build an end-fed half-wave antenna using FT240-43. Now the construction is same. Only thing is I'll be using a much more efficient toroid. This is known as the fatty toroid of material 43, but it doesn't have a fancy FT240 or anything. This is actually 240 is 240 mm. The width of the toroid, this is 39 mm, but it doesn't have that fancy nomenclature. So this there are some details on this. This is ideally called just a fatty toroid. It's available from DigiKey or VU3CER or myself. You can ping me. The name for this toroid is just a number 26432510002. You can search this on DigiKey and import it yourself. So like I mentioned, the outer dia is 39 mm, inner dia is 16 mm, and then thickness is 22 mm, this one, right? FT240-43. I don't have one lying around just for comparison, but I'll do that some other time, right? So we'll be using this to build a end-fed antenna, and I'll be using a much smaller box because this is smaller, and if you use a bigger box, it kind of defeats the purpose of having a smaller core. Not just that this is a smaller core, this is also extremely highly efficient core. FT243 efficiency wise on 40 meters will run you about 60-65. This will go up to 85-90% efficiency in terms of transmission of the power that you are providing this antenna, right? How much power goes out of the antenna is about 90% of what you provide, right? And the same specs remain in terms of the antenna element. It still will be building a 49:1, so we'll still have a 19.5 meter antenna radial, and will not be needing a coax, the counterpoise, because the coax itself will act as a counterpoise. I'm assuming you'll use a minimum RG58 as the coax. If you use RG213, much better, but RG58 and upwards is more than efficient or more than sufficient for to act as a counterpoise. So in the box that we'll be using, I have some stuff that I'll explain. So this is the box I'll be using to house this end-fed. There are some inserts that I've cut, which will be keeping it here. I have not yet. I'm thinking of preparing a bottom board and screw that, or a PCB to just push this in. I'm working on that right now. It's not ready. Once it is ready, probably I'll get that printed, and then it'll be much simpler to just use the holes here to build everything on the PCB and then push it and screw it in, right? Right now we'll just use the thermoform to keep this and seal that in once we have wound this, right? So what else do we need? We have the waterproof box. This is waterproof box. It's available in Bangalore itself. You don't have to go elsewhere. Then we'll be using this eye bolt. This is a stainless steel eye bolt. As far as I know, the only place you can get this is eBay. That's where I get it from. And this is M5, right? We get M8 and above in Bangalore. That will be too clumsy for this. It'll be too bulky and clumsy. So I'm using M5. And the stainless steel nuts, please use stainless steel and nothing else for this, right? And then this is our antenna element connector. So I've made some markings for this. So this is where the eye bolt will go. So imagine if the the toroid sits like this, the eye bolt will sit here, right? Eye bolt will sit here, and then the antenna socket will sit here. So 239. I'm still deciding whether to put the flange inside or outside. The advantage of putting the flange outside is we can glue that in, and we get much more bigger surface area to glue it in. If we put it in inside, it'll be snug inside. I'll have to see the spacing because of the box size. The box is 70 by 70 by 50 mm. It's a very snug fit box. So I'm just still trying to figure out the placements. We'll figure out as we go along. And here I have the antenna point. Since we have the eye bolt here, if the wire comes across like this, we'll put a loop around it and then put it here. So it makes sense for us to put the wing nut here for the antenna radial. I'll do that here instead of this. Just know that we don't have a counterpoise. I'll not be providing a counterpoise because the SO239 will itself act as a counterpoise. And so far, wherever I have not used a counterpoise, and the one time that I used a counterpoise, it did not help much in terms of adding any noise reduction or anything, right? So I'll not be providing a counterpoise. That will save us one additional screw, right? And what else? We'll be needing, I'm just showing what all we need. We'll be needing two zip ties, so that once we roll the wire onto this, we'll just snugly put it in zip tie. We'll need some thread. I'll be using this thread. Why do we need this thread? We'll first make a wire wounding of this, so that we'll get the exact measurement, and then we'll use this special Teflon wire. This is a very nice wire. I've already built a couple of infrared antennas using this, and it works fantastic. It's a little difficult. It's a little thicker than, or probably about the same size as the enameled core, but it's much better because it has a coating, and over the edges it won't scratch much. And the inner copper is also enameled, so that is good. And I'll be showing you how to wind this and everything. It's a little difficult to wind with this, so you need some patience to get the winding angle correct. And the winding that we'll do is 2 twisted primaries and then 12 single turns. We will not be doing crossover like we did with FT24043. FT24043, the winding pattern is 2 primary, then 5 single secondary, and then crossover, and then another 7 secondary. So that is 2 plus 7, 7, 14. Here it will be 2 primary plus 12 or 14. I'll just check it out. I think it should be 12 because overall it should be 14, right? So we'll figure that out in the next video on the winding. So that is pretty much it, all we need. And the last one is, don't forget this caps. These are Toshiba make caps, and it's supposed to be excellent, and provided by my fellow ham VU3CR Dhiru Kolia. I hope to use it this time. I've been using generic caps so far. This is supposed to be excellent, and it is I'll get the exact specs. I know it is 100 picofarad, 3 kilowatt or 5 kilowatt. I'm not sure. I'll get the exact specs and put it out in the bill of materials in the YouTube, the video description. Don't worry about that. I'll give you the exact specs, or just call up Dhiru VU3CER and then ask him to send you the caps for the infrared. He'll send you. I think this one runs about 40 per unit, right? Okay, so these are all the material that you need to build a fantastic infrared. And the antenna, how many bands do you get with this, right? If you are using antenna element of 19.5 meters, you should get 4 bands, 40, 20, 15 and 10. If you use 10 meters, you will get 20 and 10 with an occasional 15. The way, because of the winding, 15 is usually a compromise. So if you use antenna tuner, you might get out of it. But if you use a 10 meter wire, then you have 20 and 10 working fantastic. If you use a 5 meter wire, you'll have 10 meters working fantastic. So it depends on the wire length you use. But this is a fantastic antenna, and the infrared that I've made out of this, I'm using it in my house, and it works just fantastic. TX is great. RX is a little noisy, but that's true for all infrareds. But TX is excellent, and you can go look up my WSPR. Right now, in fact, even now putting out WSPR with just 1 watt, and I'm able to reach across the world, all the continents, right, using the infrared. Fantastic stuff. Okay, let's come back and let's start building the toroid first, and then we'll get onto the box and the soldering and everything else. Thank you. I'll be back.